Hello everyone, and welcome to this video on the Python programming language and machine learning. So in this video we're going to create a program that classifies patients as having chronic kidney disease or not using artificial neural networks. And right now I'm currently on Google's website called colab.research.google.com to make it easy for everyone to get started writing their Python code. So you don't have to install Python onto your computer. You can just go to this website and then log in using your Google account and immediately get started programming in Python. So let's go ahead and start writing our program to classify these patients. And to do that, we need to go up here to File and then go down to New Python 3 Notebook. And then a new tab and a new cell will open up for us where we can start writing our Python program. And the first thing that we're going to do is put a description of the program of what it does. And we're going to do that in comments. So I'm going to say description here. Okay, and we're going to write this description so that way we know what our program is supposed to do when we look back at it, and other people who are reading the code can do the same as well. So this program classifies patients as having chronic kidney disease, or CKD for short, or not. Okay, and we're going to do this using artificial neural networks, or ANN for short. And of course, artificial neural networks is just a subset of artificial intelligence and machine learning. Okay, so let's go ahead and create a new cell by clicking this code button here. All right, and now what we're going to do is import our libraries. So this will make it easier for us to write this program. So here I'm going to put import libraries, and we're going to import glob. Then from keras.model, I think it's models with an S, we're going to import sequential and load underscore model. Okay, then I'm going to import numpy and give it an alias as np. Then I'm going to import pandas and give it an alias, so we're going to call it pd. And from keras.layers with an S, we're going to import dense. All right, and from sklearn dot model underscore selection, we're going to import train underscore test underscore split. And then from sklearn dot preprocessing, we're going to import label encoder and min max scaler. Okay, and then I'm going to import matplotlib.pyplot as plt. And then, just in case I missed anything from Keras, I'm going to import Keras as K. All right, and I should let you all know that the two machine learning libraries here that we're using are Keras and sklearn. All right, so let me go ahead and run this to make sure I have no spelling mistakes. And I'm running it just by clicking that button here. All right, looks like everything's good because we have no error messages. So I'm going to create a new cell again by clicking that code button. And here we are going to load the data. Okay. Now, actually, no, before we load the data, I just kind of want to say that it's pretty neat that we might be able to identify these patients as having kidney disease or not based off of just data and using artificial intelligence. So now the patients, once this disease is identified, they can then take preparations to monitor it, maybe to do some things to help prevent it getting any worse, maybe prepare for surgery, things like that. So it can really save people's lives in the long run just by using data and machine learning and artificial intelligence. So I think that that's amazing, and the medical field could use many data scientists and programmers to do things like this. All right, so anyways, let's go ahead and continue now that my rant is over. So we're going to load the data, and in order to do that, we need to use Google Colab's library. So let me say that again. We need to use Google's Colab's library. All right, so from google.colab, let's import files. Okay, and then we'll create a variable called uploaded and set it equal to files.upload. All right. Now, of course, this library allows us to upload files from our computer. So I'm going to create a variable called df, which will be short for data frame, and set it equal to our pandas.read underscore CSV method. And within that method, I need to give it the name of the file that I want to read. So the name of the file is called kidney underscore disease.csv. All right, and then let's print the first 5 rows of data. So to do that, just type df.head method, and then let's run this. Okay, so now we get to choose our file. So I'm going to click choose files here, and then I'm going to choose kidney disease, and let's open that here. All right, excellent. So now we get back 5 rows of data, and remember that each row represents a patient, and then of course the columns are the data points for each patient. Okay, so we have the column called ID, which of course is the identification of the person. We have the age, and the age is the age of the person. We have BP, which stands for blood pressure, SG, which stands for specific gravity, AL for albumin, SU for sugar, RBC for red blood cells, PC for pus cell, PCC for pus cell clumps, BA for bacteria, BGR for blood glucose random, BU for blood urea, SC for serum creatinine, SOD for sodium, POT for potassium, hemo for hemoglobin, PCV for packed cell volume, WC for white blood cell count. And I'm going to scroll over here. We have RC for red blood cell count, HTN for hypertension, DM for diabetes mellitus, CAD for coronary artery disease, APAT for appetite, and PE for pedal edema, and ANE for anemia. And then of course we have our classification, which has a CKD in these values here. So the values here are CKD in classification, which stands for, of course, chronic kidney disease. So it's identifying these patients as having chronic kidney disease. So the classification will tell us if the patient has the disease or not. All right. Now let's go ahead and create a new cell by clicking that code button. Okay, and here what we're going to do is get the shape of the data, and I'm going to put that in comments. Get the shape of the data. And what do I mean by get the shape? I mean get the number of rows and columns. Okay, so to do that, we just type df.shape, and then we run this, of course, using that button on the side there. All right, and we get back 400 rows of data. So that means that we have 400 patients in this data set, and 26 different data points on each patient. Okay. All right, so let's go ahead and create a new cell. Okay, and in this cell we are going to we're going to create a list for the column names that we want to keep, or for the columns that we want to keep, and we can do that by creating a list and storing the column names in that list. So here I'm going to create a list of column names to keep. Well, it's really a list of columns, but I mean it's a list of column names, but we're going to keep the columns. So we're going to do this later on. For now, just trust me, we're going to put column names in this list. So I'm going to create a variable called column underscore to underscore retain, and I'm going to set it equal to an empty list. Okay, and now within that list, I want to put the names of the columns that I want to keep. So I want to keep SG. I want to keep AL. I want to keep SC. I want to keep Hemo. I will keep PCV. And I will keep wbcc. Then I will keep rbcc. And I will keep htn. And then, of course, we'll keep classification. All right. Okay, so let me scroll down here, or go down. So now we're going to actually change our data set a little bit. So we're going to create a new data set without any other column except for the columns that we want to retain. So we're going to drop the other columns. So we just say df, or write df dot drop method. Okay, and inside of this method here, we're going to tell it what columns we want to drop. All right, so let me just put some space here to make it look a little bit better. So we're going to drop columns for columns in the data frame dot columns. So of course, df dot columns has all of the column names in it. Okay. Now, if the column is not a column in the columns underscore to, and actually I'm gonna make this a S. I'm gonna put columns, not column, because it's gonna be multiple columns. So columns underscore to underscore retain. So if it's not in this list, then I want it to return those column names. Okay. And since we're in this drop method here, that's just one parameter that we're inputting. Then I'm going to put in another parameter. So we need comma, and I'm going to put in the axis. So I need to tell it to drop the column. And to do that, I just set axis equal to 1. And now, again, like I said, I want to recreate our data set. So I'm going to set df equal to this new data set with these now dropped columns. Okay. And let me see, I should definitely comment this. So here we drop the columns that are not in columns underscore to underscore retain. Okay. Now let's also drop the rows with NA, or missing values. So to do that, we just type df dot drop NA, and I think by default it drops the rows, but because I'm not sure, I'm going to set axis equal to 0. So that will tell me, that will tell this method here to drop the rows. And I want to store this new data set back into our original variable. So df is going to be equal to this new data set here. Okay, so now what we've done, just to review, we created a list of column names that we wanted to keep. We then dropped the rest of the columns, and then we removed or dropped any missing values in the rows. Okay, so I'm going to go ahead and run this, and let's create a new cell. All right, so now what we're going to do is transform the non-numeric data. So the non-numeric data in the columns. All right, so to do that, I need to go through every single column and then identify the column that isn't a, or that does not contain values that are numbers. And if there is a column that contains values that are not numbers, then we're going to need to transform them into number values. So again, we're going to need to loop through all the columns. So for column in df.columns, all right, so we're just using a for loop here. If that column, so df column, if its data type is equal to a number, so if it contains number values, then we don't do anything. So we just continue. Okay, but now if it doesn't, then we want to transform that column. So the df column is going to be transformed. So it's going to be equal to our label encoder. So this is the method that we imported. That's going to help us transform the data into numbers. So we do label encoder dot fit underscore transform. And what do we want to transform? We want to transform that specific column. So df column. All right. And I think that looks pretty good. Let's go ahead and run this. Hopefully there's no errors. All right, it looks good. All right, so let's create a new cell here. And I just want to print the first 5 rows of the new cleaned data set. So to do that, I'm just going to type df.head and let's run this cell. All right, and now we can see our data has been transformed. For example, the columns HTN and classification are now numbers where before they were not. So if I scroll up here, you can see that HTN has yes and no. So they weren't numbers before, and classification of course has CKD, but now we have 0 for CKD here. So that tells us that the patient here, when we see the 0 value, that is equal to them having chronic kidney disease. Okay, so this tells us that 0 tells us that the patient does have chronic kidney disease. All right. All right, so let me see what else we need to do. We need to split the data into independent and dependent sets. So let's create a new cell. And here we will split the data into independent, we'll call it X, independent X, data set, and dependent, we'll call it Y data set. Okay, and so the independent data set contains the features. So maybe I'll put that here, split the data into independent X data set. So I'm gonna put features here, the features, and dependent Y data set. So this is the target. Okay, so let's go ahead and create some new variables. So one I'll call X, and I will set it equal to all of the features in our data set. So that means that by all the features, we mean every single column that's in our data set that we will use to determine what the target variable is, or everything except for the target. So we could do something very simple here. We can set X equal to df dot drop. And so all we have to do is drop that one column. And what's that column name? That column name is classification. Classification. So that's our target column. And again, because we're using that drop method and we want to drop the column, we need to tell it that we want to drop the column. So the X is going to equal 1. Okay. All right. So now let's create our dependent data set, or our Y. So I'm creating a variable called Y and setting it equal to df classification, because it contains the target that we want. All right, and so that's it. So that's pretty simple. So let's go ahead and run this. Okay, everything looks good. Let's create a new cell. All right, now here we're going to do something called feature scaling. Okay, and now of course the X data set is our feature data set, so that means that we're going to scale our feature data set, and we're going to use something called min max scalar method, which scales the data set so that all the input features lie between 0 and 1. Okay, so let's create a variable called x underscore scalar and set it equal to min max scalar method, and then x underscore scalar dot fit x. Then we'll create a variable called column names and set it equal to x dot columns. And let me see here, make sure I'm doing capital X. Okay, capital X, yes, capital X. All right, just making sure that everything looks good here. Okay, so now we have all of the column names from the X data set. So X column names is going to be equal to x underscore scalar dot transform x. Okay, and now let me go ahead and run this. All right, everything looks good. Let's create a new cell. So what we just now did, and I guess to just kind of review everything, we've now, let's go all the way up to here. So we've transformed our data into numeric data. We printed out the first 5 rows of our new clean data set. We've split the data into the features, which is the X data set, and the target data set, which we call Y. Then we did feature scaling to make sure that the values in our data set lie between 0 and 1. Okay, and now we're going to split the data into 80% training and 20% testing. I put 30% there, so 20% testing. All right, so to do that, we're going to use that train test split method. So just type train underscore test underscore split, and we need to tell it what data sets to train on. So we want to train on the X and Y data set, and then we need to tell it the test size. So the test size is going to be 20%, which is 0.2, and this automatically tells the method here that the training data set is 80%, right? Because 1 minus 0.2 is 0.8. So again, test size is 20% or 0.2, and now the training size is 80% automatically. Okay. All right, and actually I'm going to do something else. I'm going to give it shuffle equal true. So this is going to tell it to shuffle the data before splitting. So here we'll put and shuffle in comments. All right, so this method returns a few values. So it's going to return x train, it's going to return x test, y underscore train, and y underscore test. So I'm going to set those 4 variables equal to this method. Okay, so let's go ahead and run this. Hopefully there's no errors. Okay, looks good. All right, let's create a new cell. Okay, so now in this cell, we're going to build the model. Okay, so to do that, we're going to use the sequential method. So I'm going to create a variable called model and set it equal to sequential. And this is like the model's architecture. And then we're going to add layers to our model. So to do that, we just type model dot add, and each layer can be created using the dense method. All right, and so within this dense method, we're going to tell it how many neurons we want. So I want 256 neurons, and then I want the activation function to be the ReLU function. Let's go back, let's go right here. Because this is the first layer, this is going to be the first layer, we need to give it something called an input dimension, which is the number of features that we have in our data set. So I'm going to type input underscore dim and set it equal to the number of columns in our data set. So to do that, I can just use the length method. Let me put a comma here. All right, so I can use the length method, and I can get the length of our x dot columns. All right, so that tells us the number of features in our data set. Okay, so we have the activation function. Um, let's see here. I'm going to do something. Let's give it a kernel initializer. So here I will type kernel underscore initializer, and I'm going to set it equal to k dot initializers dot random underscore normal, and then give it a seed equal to, let me just do 13 for now. Okay, so now that gives us, let's see, one parameter here, so 256 neurons. Our input dimensions, so we're only going to need to use this one time, only for the first layer, to tell it the number of features in our data set. We have the kernel initializer, and for those of you who don't know, the kernel initializer is a initializer that generates tensors with a normal distribution. All right, so an initializer basically defines the way to set the initial random weights of the Keras layers. Okay, and then we're just seeding it here. And all right, so we have an activation function called ReLU that we're using. So everything looks good for our first layer of our artificial neural network. All right, so I think that's good. Let me add another layer. This will be the last layer, so model.add. And in this layer, we're still going to use dense. Okay, only want one neuron, so we're going to put one here for one neuron. And I want this activation function to be sigmoid. Actually, I'm going to use hard sigmoid. Okay, so we're going to use the hard sigmoid function. Okay, so let me go ahead and run this. Hopefully there's no errors. And there are. I figured there would be. Keyword argument not understood, activation. All right, activation here. Look like I did some misspelling, so it's just activation. And let's run this again. All right, so now everything looks good. Okay, great. Let's create a new cell. And now we're going to do something called compiling the model. All right, so to do this, we just type model.compile. And inside this method, we give it a loss function. So we set loss equal to, I'm going to use binary underscore cross entropy. So this is a function used for binary classes or two classes, right? So in this case, we have two classes. Either a person has chronic kidney disease or they don't. So those are our two classes. Let's see. Also, if you don't know what a loss function is used for, well, the loss function measures how well the model does in training and then tries to improve on it using the optimizer. And speaking of the optimizer, we need to tell it what the optimizer is. So the optimizer is going to be, or is going to use the atom optimizer. Okay, and then of course we're going to give it some metrics because we want to check the accuracy of our model. So the metric is going to equal accuracy. Okay, and now I think I can just run this and everything should be good. Okay, let's go ahead and create a new cell. All right, here we're going to train the model. So it's going to train on our training data set. So I'm going to create a variable called history, and I'm going to set it equal to model.fit. So that fit method is another name for train. So we're going to be training the model in this method. And again, we have to give it the training data set that we're going to be using. So that's x underscore train. and y underscore train, which we created when we split the data, right? So what else do we need to give it? I don't think it's really necessary to give it the epochs. I think it has a default. I have to check that later on, but for now we'll give it um, a epochs value. And epochs is the number of iterations over the entire data set to train on. So we're just going to give it 2000. And then I'm going to give it a batch size. And the batch size is basically the number of samples per gradient update for training. So the batch size will be the, let's see, what number do I want to give it? You know what? Let's give it the number of patients in our data set. So that's x underscore train dot shape, and we're going to get that. We're going to get the number of rows, right? So that's at position 0. Okay, so that looks good. All right, so what we're going to do is I'm going to click this button here, and it's going to start training the model, and it's probably going to take a while because I have 2000 epochs here to train the model. But what I'm going to do is pause the video and then come back when it's finished, and then we're going to continue on. So let's go ahead and run this. Okay, and now the training has started. Okay, so our model is done training now. So let's go ahead and create a new cell. And in this cell, we are going to save the model. And to do that, we just type model.save, and then we give the model a name. So ckd.model will be the name of that file. And then we can just run this here and the model is saved. Okay, let's go ahead and create a new cell. And although we see the information here on the training data, if we scroll down, let me see, let me actually scroll all the way down on the training that the model did. So we can see the loss is 0.0068, and we can see the accuracy is 99.56%, which is pretty good. But let's visualize the model's loss and accuracy. So to do that, we're going to type plt.plot history ACC, which is of course the accuracy. Then I'm going to copy this by highlighting it and clicking on Control C, and then coming down here and clicking Control V to paste it. And then we're going to change ACC to loss. All right, so we're going to plot this visually. We're going to give our plot a title, and we'll call it model accuracy and loss. And then we'll give our plot a label on the y-axis. So plt.y label is going to be the accuracy and loss. And then we will give a label on the x-axis. So plt.x label will be epoch. Okay, and now let me run this. Okay, so now we can see visually our model's accuracy and loss as the number of epochs increases. All right, so we're pretty much done here, but I want to see how this model does in predicting whether or not a patient has CKD, chronic kidney disease. So let's go ahead and create a new cell. Okay, and to do this, first thing I want to do is I want to print the shape of the training data. Let's print the shape of the training data and the shape of the test data. So let's see what that looks like. So print shape of test data. So to do that, we say x underscore train dot shape, and then I want to print the shape of the, or shape of, sorry, shape of test data and shape of training data. Let's do that. Yeah. So let me go up here. I'm going to call this training instead of test, because yeah, there we go. So shape of training data and shape of test data. So x underscore test dot shape. And so if I run this, x underscore train, and that's because these supposed to be capital X's here. So that's why I got that error message. Let's run this again. Perfect. So now we can see that the training data had 229 patients or rows in 6 columns, and then the testing data had 58 patients and 6 columns, or 58 rows in 6 columns. All right. So let me go ahead and create a new cell. Like I said before, I really want to see now how well our model predicts and predicts and diagnose patients. So let's do that now. I'm going to create a variable called pred for prediction, and I'm going to set it equal to model.predict. Okay, and we're going to predict on the testing data set, so x underscore test. And when we use the artificial neural network, we get back probabilities. So for example, let me just type pred here and run this. Right now, oh, there we go. I was about to say, it looks like there are no probabilities here, but 0 and 1, 0% and 100%. But we can see some probabilities here, like 0.8568 and 0.3205. Okay, let's see if there's any more. Yes, so here's a probability as well. So this doesn't really tell us if the person if the person has chronic kidney disease or not. It just gives us a probability. So I only want values that are 0 and 1. So to do that, I am going to set pred equal to a 1 if we'll call it y, if y is greater than or equal to 0.5. Else we're going to set it to 0, and this is for y in the pred data set. Okay, so this is our threshold. So 0.5 will be our threshold. This will change the data to a 1 or 0 depending if that value is greater than or equal to 0.5. So for example here, 0.85687757 will now become 1, and the one below it will become 0. So let's go ahead and run this again. Okay, and so now we'll see that we don't have any more probabilities. They're all 0s and 1s. So that tells us, if the patient has chronic kidney disease or not. All right, and then also want to show the actual values. So let's go ahead and create a new cell here. And here we're going to show the actual values. So we're going to show if the patient actually has chronic kidney disease or not. And to do that, we just type, I believe it's y underscore test. Okay, and so let me run this. And so this tells us, if the people have CKD, chronic kidney disease, or not. And what we can do is we can match them up together, right? So let's actually do that. I don't like the way that this is being printed right now, so I'm going to delete the cell. Let's go up here and we'll keep this cell. I'm just going to get rid of this here. All right. And what we're going to do is we're going to put them basically kind of side by side. So we're going to print the original values. All right. So just trust me here. We're going to use something called format. and we're going to separate them by commas here. So format, I could use dot join, and we can get x for x in y underscore test, and x needs to be a string, so I need to cast it as a string. Okay, so hopefully that looks good. I'm going to basically copy this and paste it here, and now so we have the original data set, and now let's get the predicted data set. So we're going to do basically the same thing, but this time for pred. Okay, and I'm going to get rid of this, get rid of that pred value there. And I need to comment my code, so I'm going to comment this here, show the actual and predicted values, and I'm going to comment this code up here. So here we're going to get the shape of the training and testing data set. All right, so let me run this. Okay, so I need to put a space here, and let's run this again. Excellent. So now we can kind of match it up a little bit better and see where there's a mistake. So it looks like right here and here. So not bad. This is a pretty decent model. So anyways, that's basically it, guys. And I hope you all enjoyed this video. Please leave any questions you have in the comment section. Don't forget to hit that subscribe button and that like button. And if you found this video helpful, please share it. And I'll be sure to put this code up on my GitHub and a link to that in the description, as well as an article for this so you guys can read it. So anyways, thank you all for watching, and I'll see you all in the next video.